going to be times when you need to calculate the measures of center from a frequency distribution, and there's an easy way to do this than what I'm going to look at right away. So first thing you want to do is you have to understand your frequency distribution. So it's telling me that my category was the number of siblings. So they could have responded with 0 siblings, 1 sibling, 2 sibling, or 3 siblings. And then this over here is telling me how many people responded to each category. So what this would look like, let's look at the 2 and the 12 here. It's telling me that 12 people said they had 2 siblings. So in my data set, that means there would be 12 2s listed in my data set if I were to actually list them all out. And I think I have 12 there. So that's what this is telling me, that there are 12 2s in my data set. So if I wanted to find the mean for this distribution, I have the option to list all my values out. So I could list 14 zeros, and then I could list 18 number ones, list my 12 2s, and list my 9 3s, and add them all together and divide by my total number of values. Now that's pretty time consuming. So what you want to think about is if I have 12 2s here that I were going to be adding together in order to find the mean, well, the shorter way of adding 12 2s is to simply take 12 times 2. And that's what we would do for each of these categories. So instead of taking 14 zeros and adding each of those zeros together one by one, and then taking 18 ones and adding them together, in order to find my mean, I'm going to take the category times the number of times it occurs. And then I'm going to take my next category times the number of times it occurs, and I'm going to add those quantities together. Okay, so I have my 0 times 14, my 1 times 18, 2 times 12, 3 times 9. Okay, when I end up getting that, I get a value of 69. Well, now, just based off of the context of the situation, that does not make sense, that my mean number of siblings is to have 69 siblings. Well, this is only the first part of finding the mean. Remember, we have to divide by our total number of values. Well, our total number of values is the sum of our frequencies. So there were 14 people that answered, 18 people that answered, 12 people that answered, and 9 people that answered. Well, all together, when I add those, I have 53 people. So I would take my total when I added them, and I have to divide that by 53 in order to actually find my mean. When I do that, I get 1.3. Now that answer seems like it could be logical, that the mean would be 1.3. It would land right about here. If we had to do the median, you're gonna do the same type of thing. If you want, you could list all the values out and then work your way towards the center, but that gets to be pretty time consuming. So what I would recommend doing is just visualize that we have 53 total points. Well, that's an odd number, so I know it's going to come down to just one value in the middle. And if I think of taking my data set and cutting it in half, so I had 53 values and cut that in half, that's 26.5. So that tells me there's going to be 26 values below my middle value and then 26 values above. Well, I'm looking for that middle value. So if I can come up into my table and find that 27th value, I would have my mean. So 26 of the high values, if I cross out those, well, I'm going to cross off those first 9. And when I do that, that leaves me with 17 that I still need to cross off to get back to that middle. So 12 is smaller than 17, so I'm going to cross off all of those. And when I do that, that leaves me with still needing 5 more values to cross off. Well, again, that's going to now land me in the category of 1. So it doesn't matter if you work from the high end or the low end when you're doing the median. Okay, to find my mode, I just need to look at which had the highest frequency. Well, 18 people said 1, so that would be my mode because it had the most responses for that particular category. And now if I need to do my mid-range, I need to take my maximum value minus my minimum value. Now make sure you're working in the categories, not the frequencies. So my maximum value is a 3. My minimum value was 0. Well, when I do 3 plus 0 divided by 2, I get 1.5. So my mid-range would have been 1.5. Now, if you're going to be working with a frequency table that has ranges of values for their categories, we don't have necessarily the best way to do it, because since we were looking at a range from 0 to 14 miles that people were driving to work, and 20 people said that they fell in that range, well, we don't know for sure how many people answered 5 and how many people answered 11. So what we have to do is we just have to use our best estimate. So in order to find the mean for something like this, we would take the midpoint of each category. So from the 0 to 14, my midpoint is 7. 15 to 29, my midpoint is 22. 30 to 44, my midpoint is 37. And then from 45 to 59, my midpoint is 52. And then I would treat it just like a single grouping category. So to find my mean, I would do 7 times 20 plus 22 times 32 plus 37 times 15 plus 52 times 8. And then I'm going to have to divide that by my grand total of values here. So when I add my frequencies together, I have 75. So when I do that full computation, I would find my mean to be 24.2. Now we're going to look at, just real quickly, the benefits and the drawbacks of each one of those. Okay, so first of all, some benefits and drawbacks for the mean. The benefits is that it uses every data value, and most people understand it. It's kind of our common mean. Okay, the drawbacks. Outliers can change that value substantially, and they can give us a false impression. So a common example that people use is salaries. Let's say you go into a restaurant and you find a table of 15 people and you compute their mean salary. And let's say their mean salary, I don't know, turns out to be $50,000. Okay, as the mean salary. Well, let's say one more person sits down and it happens to be a multi-millionaire. I mean, millions and millions of dollars. Now, when you add their salary into it, now let's say the mean salary all of a sudden jumps up to $200,000 for the mean. Well, that's not actually a good representation of our data set, because those original 15 people, they haven't made any more money. They're still averaging, have a mean of $50,000. But because that one incredibly wealthy person sat down, the mean salary jumped up to $200,000. So that's a misrepresentation of the group as a whole because of an outlier. Okay, now median. The benefits of a median is that outliers have very little impact because the value of the numbers is not important, it's the position. So if that really, really rich person happened to sit down at the table again, the median would not jump that much, because it might jump from, let's say our middle values were 40,000 and 50,000. Well, when we tack one more person onto the to the end, it's only going to shift it one position. So the fact that this person is millions and millions and millions of dollars doesn't matter. Okay, all data values are still considered when we're doing the median, because we still have to arrange them in order. And then another benefit is we know that half of the values lie above the median and half of the values lie below the median. Okay, now the drawbacks of the median seem a little bit strange, because the fact that the median is not sensitive outliers is actually one of its main drawbacks. So let's say, for example, there's this rare disease that's fatal, but they've found a new treatment, and they have reported that the median lifespan, if you do this new treatment, is 2 weeks. Now, 2 weeks doesn't really seem like that big of a deal. So people may or may not choose to do the treatment depending on the expense of the treatment and possibly the side effects and things like that, because 2 weeks isn't really that much of an extension of a person's life. But now let's say that what the median doesn't show us is that 40% of individuals that do this treatment are completely cured. So for simplicity, let's say I have 5 individuals here that have this rare disease and do this treatment. Now let's say that the 40% would represent these 2 people right here are completely cured. So their life increase, let's say it's 70 years that their life is increased by. And then let's say that the next person's life was increased by 2 weeks. The third person's life was increased by 0 weeks, and the fourth person's life was increased by 0 weeks. Well, if we only look at the median, that's where we come up with our individual of 2 weeks. Now, only using that 2 weeks as the value that you use to make your decision would not be a good idea. Because if people know that there's a 40% chance that they could be completely cured, that would probably have a big impact on their decision. But the median does not show us that. So in this case, if we were to compute the mean for our data set here, we would come up with a value of many, many years that your life would increase by. So in this case, it would be by just over 35 years for your mean life increase. Now that would also be a number to consider, because then people would probably be more likely to consider the treatment. Okay, so you have to be, you have to really think through, do outliers, are they important for the situation or are they unimportant? And then that'll help you determine whether the mean or the median would be a better representation of what you want to do. Okay, now with the mode, the benefit of the mode is that it can be used for categorical data, where we can't really do that with the mean or the median. The drawback is that there can be many modes or no mode at all, so it depends on our data set. And another drawback is that it might really not depict the middle of the data set, because if we have a small data set and it just happens to be that maybe the highest value happens twice and everything else happened once, well, that would become the mode, and that really wouldn't give us an idea of the middle. So the mode is not used quite as often as these other ones. Okay, and then the last one, our mid-range. Benefits of the mid-range: it's easy to compute. It's pretty easy for people to understand. Drawbacks: it does not use all of the data, which means it's sensitive to outliers. So it might not represent the middle. So it's kind of like the mean, where outliers can really change its value. But then again, we have to decide, are outliers actually important to understand, or are they not important? So this is just a quick summary of them. This is by no means all-inclusive, but just some things to think about. Now, the best case scenario, if you're doing a research project or looking at a data set and trying to analyze it, you would want to compute all of these values and then do some comparisons to try to figure out what's your data really showing you.